Hi guys, so today we're going to be talking about SOH CAH TOA in inverse trig. And we can use this to find missing sides or missing angles on right triangles. So let's look at our first example here. So we have SOH. Well, that's going to stand for sine of theta equals opposite over my hypotenuse. So where did I get those words? Well, sine, opposite, hypotenuse. That's where I get those words from. So let's move on to my first example. So I have theta down here. So that's important to note that it's in the bottom corner. So I see that my hypotenuse is going to be my longest side, which is right here. And then it is going to be the opposite side is over here. And this is our missing side length. So I'm going to label it as X. Alright, and then we have my adjacent side right next to my angle. So now we have sine of theta equals opposite over hypotenuse, and this is how I'm going to be abbreviating things from now on. Those are pretty big words that I don't want to write. Alright, so we know that theta in this case is 36.87. Okay? And then let's look at for our opposite. So opposite is going to be my X. And then my hypotenuse is also given to us as 35. So from here, I'm going to solve for X. I want to get it by itself. So I'm going to multiply by 35 to both sides. So then I have 35 times the sine of 36.87 is equal to X. And we can go ahead and put that into a calculator. So let's go to Desmos. So we have functions, sine of theta, which was 36.87. And then we're going to multiply that by 35. Well, I get a negative number. You're probably thinking, that doesn't work, Miss Smith. You're right, it doesn't. So I'm going to go to this little wrench right here, and it says graph settings. And I'm going to look down here, it says radians and degrees. We want to keep ours in degrees. So when it does that, we get a nice number of 21. So you can say that X equals 21. So let's move on to our next example. So what if we had all our sides but no angle? So let's say we're trying to find our theta up here. So you have 21, 35, and 28. And we know that sine of theta equals opposite over hypotenuse. So then we find, we're going to label our triangle. So hypotenuse is our longest side. Opposite down here this time, and adjacent right next to our theta. So knowing that we have sine of theta equals opposite, well, opposite is our 28 this time over my hypotenuse, which is 35 this time. And so now we have sine of theta equals 28 over 35. Well, how do we find theta? We can take this wonderful thing called the inverse sine of both sides. And then what happens is the inverse sine and the sine cancel. So we have theta equals the inverse sine of our fraction. Let's say 35. So what can we do from there? Well, we can go back to Desmos, and Desmos will tell us what that is. So we have the functions inverse sine of 28 over 35. and we get 53.13. So we say that theta equals 53.13. So now we have CAH. So we have to say cosine of theta is equal to the adjacent over hypotenuse. And again, I get that from our abbreviation, cosine, adjacent, and hypotenuse. So let's move on to our example. So we have this wonderful little triangle on the left here, and we have a side length of 30 and 16 and a theta of 61.93. So let's go ahead and label our triangle first. So we know that our hypotenuse is this longest side, and opposite is going to be across from theta. This is opposite, and right next to our theta is our adjacent. So remember, cosine of theta equals adjacent over hypotenuse. And then cosine of theta, well, we know that theta is the 61.93. And then adjacent, well, it tells us we have 16 for my adjacent. And then we don't know our hypotenuse, so it's x. Okay? So now we have to do is solve for x. So if we solve for x, we're going to multiply by x to both sides. And then our x's cancel, so then we have x cosine of my theta is 61.93, and that's equal to my 16. Well, we need to get x by itself, so we're going to divide by my cosine of 61.93 to both sides. And so now we have x equals 16 over my cosine of 61.93. So now we can go ahead and plug this into Desmos to figure out what my missing side length is going to be. So let's go to Desmos, and we have 16 divided by functions cosine of 61.93, and then we get that it's going to be 34. So x equals 34. Alright, so let's move on, and let's try and find a theta this time. So theta is going to be this guy right here. And I want you to label your triangle first, and pause the video here and label that triangle. So if you did this correctly, you should have 34 as your hypotenuse, 16 as your opposite, and 30 as your adjacent. Alright, so let's put these into our formula. So I already wrote it down. Cosine of theta equals adjacent over hypotenuse. So we know cosine of theta, and then adjacent, well, adjacent we labeled as 30 over my hypotenuse, which was 34. Okay, and then from here, like we did before, we're going to take the inverse cosine. So each of these have an inverse that goes along with it. So just like before, they cancel out the inverse and the normal. So we have theta equals the inverse cosine of 30 over 34. Now 35. Okay, so now let's go to Desmos and find out what theta should be. So again, functions, inverse cosine, and then 30 over 34. And if you're doing this along with me and you're wondering, why am I getting something not the same? Remember what I said. Go to the wrench and make sure you're in degrees. Make sure you're always in degrees. Okay? So you get 28.07 for my theta. Awesome. Alright, let's move on. So now we have TOA, and that's going to be my tangent. So tangent of theta, not tan, equals opposite over adjacent. So this one we don't have to deal with the hypotenuse at all. So again, I get tangent, opposite, adjacent. So let's look at our first example. So we have this wonderful little triangle on the left. Alright, so we know our theta is 36.87. Alright, knowing that is our theta, I want you guys to go ahead and label this triangle by yourself. So pause the video here and label that triangle. Alright, so you should have gotten 35 is our hypotenuse, the missing side is our opposite side, and 28 is my adjacent side. Alright, so now we can go ahead and plug things in. So tangent of theta, well, we know that theta is going to be 36.87. That's going to equal my opposite over adjacent, and opposite in this case was my x, and then over my adjacent, which was 28. Alright, so now we need to solve for x. So I'm going to multiply by 28 to both sides. And so I now have 28 times the tangent of 36.87, and that's going to equal our x. So I'm going to go into Desmos and just type that in. So we have 28 times functions tangent of 36.87, and we get 21. Alright, so we know that x equals 21. And it had some decimals, but it was a very small amount, but it's very close to 21, then I'm just going to say 21. Alright, last but not least, our last example, and this is with tangent. So again, tangent is opposite over adjacent, and I want you to find the sides when theta is in that top one. So pause the video here and find those sides. Alright, so if you did this correctly, you should have gotten 35 as our hypotenuse, 28 as the opposite side, and 21 as the adjacent side. I'm going to set up the equation for you, but then I want you to find the answer on your own. So setting it up, we have tangent of theta, opposite and adjacent, and that's going to be 28 over 21. And now I want you to find what does theta equal. So pause the video here and find what theta equals. If you did this correctly, you should have gotten 53.13, so you're going to take the inverse tangent of both sides, and so you have the inverse tangent of 28 over 21, and you'll get that answer once you put into Desmos. Alright, that's it for today's video. Have an awesome day, and stay safe out there, guys.